Welcome to the video for section 7.2, Sum and Difference Identities. By the end of the lesson, you'll be expected to use sum and difference formulas for cosine, sine, and tangent, use sum and difference formulas for cofunctions, verify identities using sum and difference formulas. Sum and difference identities for cosine. Let's start with these. We have cosine of A plus B, and of course these are angles, equals cosine of A times cosine of B minus sine of A times sine B. Cosine of A minus B equals cosine of A times cosine of B plus sine of A times sine B. Next, let's look at sum and difference identities for sine. We have sine of A plus B and sine of A minus B. So for this first one, we have sine of A times cosine of B plus sine of B times cosine of A. And for the difference identity, we have sine of A cosine of B minus sine of B cosine of A. Next, let's look at the sum and difference identities for tangent. Tangent of A plus B is equal to tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. Tangent of A minus B equals tangent of A minus tangent of B divided by 1 plus tangent of A tangent of B. Finally, we have our cofunction identities. We have cosine of pi over 2 minus A equals sine of A. Sine of pi over 2 minus A equals cosine of A. Tangent of pi over 2 minus A equals cotangent of A. Cotangent of pi over 2 minus A equals tangent of A. Finally, we have secant of pi over 2 minus A equals cosecant of A. And cosecant of pi over 2 minus A equals secant of A. Let's look at example 1. Example 1, using cosine, sum, and difference identities. Find the exact value of the following: cosine of pi over 3 minus pi over 4. So if you recall our cosine difference identity, cosine of A minus B is equal to cosine of A times cosine of B plus sine of A times sine of B. So using that, we have cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. Now the cosine of pi over 3 is 1/2. The cosine of pi over 4 is root 2 over 2. Then we add the sine of pi over 3, which is root 3 over 2, and the sine of pi over 4, which is root 2 over 2, to end up with root 2 over 4 plus root 6 over 4, or root 2 plus root 6 divided by 4. Note, please do not, warning, do not make this algebra mistake. Root 2 plus root 6 does not equal root 8. I know it's really tempting to want to add these together. You see a 2, you see a 6, they're both under a square root, but they are not like terms. If you had 6 root 2 plus 5 root 2, you could add these to 11 root 2, since these are like terms, but these here are not like terms. Let's look at the next page. For the last part of the example, that is for part A, we were already given something in here that added to our angle. For the last example, we had pi over 3 plus pi over 4. But for this example, we have to figure out what nice angles have a sum or difference of 75 degrees. There are a couple ways you could do this. Notice that 90 degrees minus 15 degrees is 75 degrees, and 45 degrees plus 30 degrees is also 75 degrees. So while it might be tempting to say use this one, we don't really have a nice measurement on the unit circle. You could go ahead and memorize it, but I'm only requiring you to know 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and multiples. I should say and integer multiples. So these are the angles we want to use. So rather than using this, let's use this. Cosine of 75 degrees equals cosine of 45 degrees plus 30 degrees equals cosine of 45 degrees times cosine of 30 degrees. Now, should I have a plus sign or a minus sign here? If you said a minus sign, you're correct, because this is a sum identity for cosine. The sign here changes, so this will be minus sine of 45 degrees, sine of 30 degrees. So I have root 2 over 2. The cosine of 30 degrees is what? If you said root 3 over 2, you're correct. And then here I have root 2 over 2 and 1/2. And we end up with root 6 over 4 minus root 2 over 2, which you can rewrite as root 6 minus root 2 over 4. Let's look at example 2. Example 2, using sine, sum, and difference identities. Part A, sine of negative 15 degrees. First, begin by noticing negative 15 is equal to 45 degrees minus 60 degrees. We can rewrite this as sine of 45 degrees minus 60 degrees. So this becomes sine of 45 degrees times what? Should I have cosine of 60 degrees or sine of 60 degrees here? If you said cosine, you are correct. This is cosine of 60 degrees. I'm going to leave a gap right here really quickly. You'll see why in a moment. Then we have sine of 60 degrees, cosine of 45 degrees. So question, what sign goes in this box? Should I use a plus sign or a minus sign? If you said a minus sign, you are correct. So this becomes minus. Sine of 45 is root 2 over 2. The cosine of 60 degrees is 1/2 minus the sine of 60 degrees, which is root 3 over 2, and the cosine of 45 degrees, which is root 2 over 2. And we end up with root 2 minus root 6 divided by 4. How can we add to 7 pi over 12? Notice that pi over 4 plus pi over 3 equals 3 pi over 12 plus 4 pi over 12. And this is precisely 7 pi over 12. So let's rewrite this as sine of pi over 4 plus pi over 3. Please pause your video now and try to write the identity without my help. So this equals sine of pi over 4 times cosine of pi over 3 plus sine of pi over 3 cosine of pi over 4. Next, you should have these unit circle angles memorized, so pause your video and test yourself. Make certain you know what these angles are. You should have root 2 over 2 times 1/2, since sine of pi over 4 is root 2 over 2, cosine of pi over 3 is 1/2, sine of pi over 3 is root 3 over 2, and cosine of pi over 4 is root 2 over 2. And you end up with root 2 over 4 plus root 6 over 4. Let's look at example 3. Example 3, using tangent sum and difference identities. We have tangent of 100 degrees minus tangent of 70 degrees divided by 1 plus tangent 100 times tangent of 70 degrees. So which identity does this remind you of the most? If you said tangent of 100 minus 70 degrees, you are correct. This becomes tangent of 100 degrees minus 70 degrees, which is just the tangent of 30 degrees. So we have sine of 30 degrees divided by cosine of 30 degrees. The sine of 30 degrees is 1/2. The cosine of 30 degrees is root 3 divided by 2. And so we end up with 1 divided by root 3. After rationalizing our denominator, our final answer becomes root 3 over 3. Let's look at the next page. Part B. Tangent of 2 pi over 3 plus pi over 4. Let's use the tangent sum and difference identities. More importantly, which one will we be using, the sum identity or the difference identity? Since we have a plus sign here, we know it's the sum identity. So this becomes tangent of 2 pi divided by 3 plus tangent of pi over 4 divided by 1 minus tangent of 2 pi over 3 tangent of pi over 4. So recall, tangent of 2 pi over 3 equals sine of 2 pi over 3 divided by cosine of 2 pi over 3. Sine of 2 pi over 3 is what? Root 3 over 2. And cosine of 2 pi over 3 is negative 1/2. So this becomes negative root 3. Tangent of pi over 4 equals sine of pi over 4 divided by cosine of pi over 4, which is root 2 divided by 2, quantity divided by root 2 over 2, or just 1. Using that, we have negative root 3 plus 1 divided by 1 minus negative root 3 times 1. And bear with me, I'm running out of space, so I got to figure out a way to reposition this. Here we go. So this becomes negative root 3 plus 1 divided by 1 plus root 3. Let's multiply by the conjugate here. Remember, we don't want to leave a radical in the denominator, so we have to rationalize this denominator by multiplying 1 minus root 3 to the numerator and denominator. And in our denominator, we'll end up with 1 minus 3. in our numerator, we'll end up with 1 minus 2 root 3 plus 3. So we end up with 4 minus 2 root 3 divided by negative 2. Now this is another place I commonly see students make an algebra mistake. This is a mistake. Don't just do that and say this is 4 minus or plus root 3. That's wrong. Instead, split this up into two fractions, 4 divided by negative 2 minus 2 root 3 divided by negative 2. Then it makes it really easy to see that here we just have negative 2 and here we just have positive root 3. Let's look at the next part of the next example. Example 4, finding a cofunction with the same value as the given expression. Write the following expressions in terms of their cofunctions. So recall that sine and cosine are cofunctions. So this can be rewritten as cosine of pi over 2 minus pi over 7. So this is cosine of 7 pi over 14 minus 2 pi over 14, which is just cosine of 5 pi over 14. And you can stop here. These don't say evaluate or round or find an answer. It just says to rewrite, and we are done rewriting it. Let's look at part B. All the cofunctions were given to you in radians on the first page of these notes, but that's an easy fix. If you recall, pi over 2 is equal to 90 degrees. So we can rewrite this as cotangent of 90 degrees minus 25 degrees, or cotangent of 65 degrees. And we're done. Let's look at the last example. Example 5, verifying identities. Verify the following identity. Tangent of pi over 4 plus x plus tangent of pi over 4 minus x equals 2 secant squared x divided by 1 minus tangent squared x. So I'm going to start here with the left-hand side so we can apply the sum and the difference identities for tangent. So the left-hand side becomes tangent of pi over 4 plus tangent of x divided by 1 minus tangent of pi over 4 tangent of x, tangent of pi over 4 minus tangent of x divided by 1 plus tangent of pi over 4 times tangent x. These are direct applications of the identities given to you on the first page. This expression is equivalent to this. This expression is equivalent to this, and we're summing them together. So this becomes, so recall, tangent of pi over 4 equals 1. So this is 1 plus tangent of x divided by 1 minus tangent of x plus 1 minus tangent of x divided by 1 plus tangent of x. So we can continue to add these together. We just need to find a common denominator. So this whole expression becomes 1 plus tangent of x divided by 1 minus tangent of x. And we're going to multiply 1 minus tan x, 1 plus tangent of x divided by 1 plus tangent of x to both the numerator and the denominator. And then add 1 minus tangent of x divided by 1 plus tangent of x times 1 minus tangent of x times 1 minus tangent of x. So on the leftmost expression, this is a perfect square. So this is just 1 plus 2 tangent of x plus tangent squared x. And in my numerator here, on the right side expression, I have 1 plus, minus 2 tangent of x plus tangent squared x. This whole quantity divided by 1 minus tangent squared x. Now, these parentheses are not necessary. I only put them in so you can visually see that this product is what's inside this parenthesis, and this product is inside this product is inside this parenthesis. So let me quickly get rid of those. If you notice, we have a positive 2 tan x and a negative 2 tan x. So let's combine those. They add up to 0, so we end up with 2 plus 2 tangent squared x divided by 1 minus tangent squared x. In my numerator, I can factor out a 2. So this becomes 2 times 1 plus tangent squared x divided by 1 minus tangent squared x. Hopefully there's alarm bells going off in your head, since this is a version of the Pythagorean identity that you should have memorized. So recall, cosine squared x plus sine squared x equals 1. If we divide both sides by cosine squared x, we end up with 1 plus tangent squared x equals secant squared x. So this becomes 2 secant squared x divided by 1 minus tangent squared x. This looks like the right-hand side, so we are done. And this concludes the lecture for section 7.2.